Hello, welcome back. Hearty welcome to you. We are solving some examples as part of matrices and determinants. We have to show that the determinant of this particular matrix is equal to product of A minus B, B minus C and C minus A. So to do this problem, one thing what we can do is we can directly apply the formula of determinant whatever you know, that element into cofactor, and but we can also use some properties of determinants which we'll see in detail maybe in the next session. For now we will use one of that property. The property says that any row or any column of this particular matrix can be written as that row plus other row. What's the meaning of that is, now before going there, now if you remember in the last video I said that whenever you have zeros it becomes easy because 0 multiplied by anything is 0. So let us see that, suppose can I make out of this 1 1 1, can I make some zeros there so that it will be easy for me. If I go to that particular column, then I will have only one term to evaluate. So for that we will use a property. The property what it says is, any row can be written as addition or subtraction of other row. That means, suppose now this is row 2, let me write it down here. This is row 2, this is row 3, this is row 1. Okay, right. We will not change the row 1, we will keep it as it is. So row 1 will stay as it is, BC, B plus C, 1. What I will do on the remaining is, I will say row 2 is nothing but assigned as row 2 minus row 1. What's the meaning of that? In element of each element of second row is subtracted from each element of row 1. That I can do. It will not change the value of the determinant. That's a property of the determinants. What happens? Why? Because when you do that, you will find out, if you do R2 minus R1, then you will see that the other matrix determinant will be 0. So the determinant will not vary. Even you have R2 minus R1 or it is R2, the determinant will remain the same. Now when I do R2 minus R1, what happens? It will be CA minus BC, correct? It will be CA minus BC. Similarly, C plus A minus of B plus C. C plus A minus of B plus C, and you can see here now 1 minus 1 is 0. This is what we are looking for. We are looking for this. Okay. Now let's go to the third row. R3 is assigned R3 minus R1. Why we are doing that? Because we know 1 minus 1 is 0 and we want to make them as zeros. Now first element AB minus BC. AB minus BC. Okay. Next, second R3 minus R1. So A plus B minus of B plus C. A plus B minus of B plus C. And this is 0. Let's simplify it further. Okay, right. BC will remain as it is. B plus C will remain as it is. 1 will remain as it is. Now CA minus BC, can I take C common? I can say C into A minus B. C plus A minus B minus C. C plus A minus B minus C. C cancels out. I will have A minus B and I have 0 here. And what about AB minus BC? I can take B common. It becomes A minus C. Then let's have A plus B minus B minus C. BB cancels. I will have A minus C and then you have 0. Now you can see, now finding out the determinant is very easy because you have two terms which are becoming 0. So I will take this column to find out the determinant. If I want to find out that particular element, then this will go off. Now that is nothing but equal to plus minus plus. So it's nothing but plus 1 into C into A minus B into A minus C, A minus B A minus B. I'll just erase that one. Okay. If I take this element, this row and column is gone. C into A minus B into A minus C. C into A minus B into A minus C minus AD minus BC. AD minus BC. Okay, right. Now minus of A minus B into B into A minus C. This is what we have now. Okay, right. Now what you can do common here, let us see. A minus B is common. A minus C is common. So I can take it common. I can write it as A minus B into A minus C. If I take that common out, I will have C here, C minus, I will have B here, that is C minus B. But this is nothing but equal to, if you write it in a pattern, A minus B into B minus C into C minus A, because C minus B is minus of B minus C and A minus C is minus of C minus A. Minus into minus becomes positive. So that's how you can do. Now only the thing you have to understand here is how I have written, why I have written R2 is R2 minus R1 or R3 is R3 minus R1. Why I have written that? Because I want to try to make the third column as much as possible to be zeros. So I want to get one or two zeros there, so that evaluating the determinant will become easy. For that, what I have done, I know a property that a row of a matrix can be subtracted or added with another row. It will not change the value of the determinant. So to simplify, I see 1 1 1. Always our approach in determinants will be like this only. We want to make as much as possible zeros. Once you make zeros, now evaluating that will be pretty easy. Now what we are doing, we are leaving the R1 as it is, and R2 we are saying R2 minus R1, R3 is R3 minus R1. When I do that and simplify it, you will get A minus B into B minus C into C minus A. We will solve some more examples. You will get a hang of it, then you will become master of it. I am sure about that. Okay, see you in the next video. Thanks for visiting. Bye for now.